So first we should know what is virtualization. Actually, the following are the topic contents. In fact, like virtualization, you should know what is virtualization, layering and virtualization. Why it is required layering, architecture wise, like in what layer it has been organized, virtual machine monitor, virtual machine performance and security isolation, architecture support for virtualization. One example, x86 support for virtualization, then full and para virtualization. These are the different kinds: full virtualization, para virtualization. Okay, and the two case studies. One is Xen 1.0 and Xen 2.0. Then performance comparison of virtual machine monitors, the darker side of virtualization, software fault isolation. These are the topic contents under chapter 5 under your third module. So the motivation to go for this is, see, there are many physical realization of the fundamental abstraction necessary to describe the operation of a computing system. See, you know that whenever we talk about the entire system or the process, it comprises hardware, software, operating system which will be working on, right? This is the normal routine. So we'll be using memory to store, communication links to communicate with other clouds, okay, interpreters to change the code into object code, binary readable format. Okay, so this is the main concept under any operating system. Okay, so computing system actually. So virtualization is a basic tenant of cloud computing. It's a part of cloud computing. It simplifies the management of physical resources for mainly three abstractions. Okay, state of virtual machine, VM, running under virtual machine monitor, VMM, can be saved and migrated to another server to balance the load. See, there will be many operating systems which will be working on top of only one hardware layer. Okay, so you can use virtualization. So virtualization allow users to operate in environments they are familiar with. Okay, so I will be looking into this mainly why it came into existence is, one part is virtualization, other one is cloud computing. Okay, virtualization is a one of the activity or one of the particular task which will be performing on the cloud computing. That is the reason it's going to be called as cloud. It's a part of tenant of cloud computing. So first you should know the virtualization. It is the ability to run multiple operating system on a single physical system. So you can run various operating system on a single physical system and share the underlying hardware resources. The same hardware resources will be using to perform various functionalities by using different operating systems. Okay, so on top of the operating system there will be many applications which will be running on from the user side, right? So virtualization is going to provide, it is a like a layer where it connects hardware and the different operating systems, okay, using the same underlying hardware actually. So hardware resources remain same. That is the main concept here. Then coming, you know the definition of cloud computing. So here cloud computing, it provides the provisioning of services in a timely, near on instant, on demand manner to allow the scaling up and down of resources. So if you know, like on Windows operating system only, like on our laptop we can connect either Windows operating system or Linux operating system. Okay, on top of Windows only, we can work on with Linux or even any other operating system you can perform. Okay, so that is the concept under virtualization. So this is main agility is, this is the one. So here cloud resource virtualization is very important for system security, as it allows isolation of services running on the same hardware, performance and reliability, development of management services offered by provider, then performance isolation. So first we will be looking into the traditional server concept. See here in the traditional server, like we'll be using it as a hardware platform. Okay, on top of that OS will be performing its functionality. OS will be running. Okay, so the storage memory concept. Okay, on top of that there will be an application layer, right? So here this is one example for web server windows. See here, the like if you are using One more OS is Linux, Windows Server, Windows operating system. Here it is Linux, Windows again. So here the so one more app server, Glassfish is going to run on this. So again, it uses the same hardware. So here, but operating system is Linux. It performs by using an operating system Linux. So in this case, here also Linux operating system will be performing the functionalities. So DB server is going to be used. Okay, and email, it works on Windows. Okay, so here there are 4 different servers which will be connected. Okay, the like a web server, app server, DB server, and email server. Okay, so everything will be running on top of the current. This is the traditional server concept. See here in the case of like here, what happens is if something goes wrong, any one of this, okay, this will be down, particular application will be down. Okay, something will also continue to work on. Okay, so in the traditional server, normally what we are going to look into the traditional server is system administrator point of view is server is a whole unit. Okay, which includes hardware, the operating system, storage, and the applications. So entire system, entire hardware, hardware components, the operating system which will be running on the particular hardware, storage, that is nothing but memory, and different applications which will be executing. Okay, so everything put together, they are going to call it as a server. But servers are often referred to by their function, that is what they are going to perform based on that email server, web server, okay, like DB server, SQL server. So like this, like whatever the operations we are going to perform, okay, or the functionalities it is going to provide, based on that we are going to call it as a server. It's not as a whole, but from the administrator point of view, it is as a whole system. So servers are often referred to by their function, that is the exchange server, the SQL server, the file server. These are few examples. You can take any number of examples. Okay, if you know that if any one of the server fails, only that particular application is going to stop. Okay, so but but the rest of the services can be performed on its functionality by using the underlying hardware. Okay, this is the traditional server concept. So before going for the virtual machine, you should know what are the pros and cons under the traditional server concept. Okay, so traditional server is it is easy to conceptualize, imagination wise, like it can be advantageous because you can easy with different servers performing its own task, fairly easy to deploy, taking the backup is also easy. Virtually any application or service can be run from this type of setup. Okay, so the drawback is expensive to acquire and maintain hardware, not very scalable. You cannot connect a number of different applications on the same server. Okay, the bandwidth and also the requirement, performance wise, it is going to be a very slow. Latency is going to be very high in such cases. Then difficult to replicate the data. Redundancy is difficult to implement. Okay, you cannot duplicate the certain performance operations. Okay, so then vulnerable to hardware outages. Then in many cases processor is underutilized. In some of the, like in some cases, even processor utilization is going to be utilized and underutilized. You cannot exploit the complete processor performance. Okay, so these are the drawbacks. So coming to the virtualization, so if you use virtual server concept, so like as we have already seen into these diagrams, so this can be here, this is the virtualization layer. Okay, in between hardware and the application os and storage, there is a one more layer which has been introduced, which performs the functionality of a virtual layer. Okay, it is an intermediate layer, virtual machine monitor, VMM layer, between guest operating system and hardware. These are the hardware components, right? Hardware which is ready to provide the services as an infrastructure as a service. Okay, on top of that you are going to run an operating system, and whatever you are running, you are going to store it in the form of a memory like storage. On top of that, application servers will be running, right? So in between the guest operating system and the hardware, you will be having a virtualization layer. See, why to go for layering in a computer system? So here, layering is a common approach to manage system complexity. Okay, it minimizes the interactions among the subsystems of a complex system. Okay, like here it acts as an intermediate layer. Any number of applications can be connected to a virtual through a virtual machine to a, it will be acting as a guest operating system actually. Okay, so to the is utilizing the same hardware. That is the advantage of going for virtual machine. It simplifies the description of the subsystems. Okay, each subsystem is abstracted through its interfaces with other subsystems. Okay, so there are a number of subsystems which will be working as DB server, SQL server, right? So they are all are going to be connected to a guest OS, which will be interacting with through a layer called virtual machine using the hardware resources. Okay, so it acts as an interface, and we are able to design, implement, and modify the individual subsystem independently. Okay, so these subsystems can be like you can add or you can upgrade or you can implement or you can modify the subsystem independently. Then layering in a computer system: hardware, software, operating system, libraries, and applications. Okay, see here in this slide we are talking about the layering concept. Fine. Okay, so here coming to interfaces, like this architecture again we are going to deal in the next slide. Okay, so interfaces consist of like instruction set architecture, that is ISA, at the boundary between hardware and the software. Okay, so to perform the operations, okay, and you will be having an instruction set architecture. Then application binary interface, which converts an object code programming library module to access hardware. ABI is allows the ensemble consisting of application and the library modules. Okay, it converts into a binary object code actually. Then application program interface, API, this you already know, which defines the set of instructions to hardware, was designed to execute and gives the application access to the ISA instruction set architecture. Okay, API provides instructions, okay, which will be interacting with the instruction set architecture. Okay, it includes even library also, HLL library calls, which often invoke system calls. Okay, this is the architecture actually. Your API, like application programming interface, how it has been connected to a ABI and ISA. This is an API, ABI, and ISA. Like instruction set architecture will be performing in the hardware layer itself, right? So system instruction set architecture and user instruction set will be performing on this through hardware. Okay, there will be a system calls which will be working in the operating system layer. Okay, on top of that, different libraries. Okay, different libraries which provides the different functionalities. Okay, in the through a different APIs. Okay, so many applications can be working on it. A1, A2, A3, A1 function. The A1 is a library function, and then makes system calls in A2. Okay, and executes machine instructions in A3. A1, A2, A3. Okay, this is one of the example for one application. Okay, normally this is the architecture, like hardware, operating system, then libraries. Okay, like here under library only, like APIs will be working on, like applications will be running here. Okay, so always hardware consists of instruction set architecture, right? It varies from different machines to machine, right? Zen might be something else, Spark is something else. Okay, Intel core is something different architecture set. Okay, it might be a 32-bit or 64-bit, depending on the kind of instruction set, how it performs. So ISA is going to be designed. Okay, so to interact with the hardware, the instructions to communicate, okay, ISC is going to be performing, or is going to do the functionalities in the hardware part. Okay, system calls, you know that system calls are going to be generated through a OS, operating system. See here, code is going to be converted by ABI, right? So instruction, so binary code portability. See, code portability is nothing but here you need to move upon binary code, which is going to be converted in ABI, which invokes the instruction set architecture, and it varies from different operating systems. As I told you, how the architecture has been designed, based on that, code portability is going to taken place. Okay, so and the dynamic binary translation also converts blocks of guest instructions from portable code to the host instruction. Okay, here host instruction and guest instructions are nothing but guest instructions are depending on the what kind of operating system which will be performing on. Host instructions are the instructions which are running raised on the application server. Okay, so this is one of the HLL code. Compiler, this is the compiler front end. So here is the compiler front end, intermediate code, compiler backend, object code, binary object code, loader, okay, memory image. So coming to the right part, that is a compiler front end. If you take out the compiler, portable code, virtual machine loader, virtual machine image, VM compiler slash interpreter, then memory image, ISA, instruction set architecture 1, and memory image, ISA 2, instruction set architecture 2. See, we are going to call it as a virtual machine monitor or hypervisor. The hypervisor, the functionality of hypervisor is also similar to a guest operating system, like VM only. Okay, but hypervisor is going to connect whenever there is a failure of any of the virtual machine. Okay, hypervisor is going to come into picture. Wait a minute. See here, when we were talking about guest and host instruction sets, right? So, like a host instruction set is how the architecture has been designed. Okay. So, for example, here ISA, the ISA for virtual machine x86, 86 for 64-bit. Similarly, Spark. See, these are the hardware architecture. Okay, hardware architecture, how it is going to be. So, normally here they have defined the name of the virtual machines as well as type of server or hardware actually. Okay, so here this is the microprocessor or the processor which performs the instruction set architecture. Okay, Zen 86, Spark. Okay, these are all like say for 64-bit. Some of them are working for 64-bit and some of them are for 32-bit. If nothing is not there, it means that it is 32-bit. Okay, guest and host instruction sets has been defined here. Then host operating system. Okay, like operating system is going to be hosted either by using Unix or no host. Only the operating system will be working on Windows, and some of them, like for example here Spark is going to be designed for same as a host, no host. Okay, it works for either Linux or Windows. Okay, Sun Microsystems. Okay, this is for Oracle, that is Oracle Virtual Machine. Okay, similarly Microsoft, they are going to call it as Hyper-V. Okay, Microsoft. Then Linux works, Linux secure. Then Power Virtual Machine done by IBM company. HP, Integrity VM, they are going to call it as Integrity VM. It is works for 64-bit. Okay, HP Unix operating system, which works on Linux, Windows, HP Unix. See, this has been listed, and before that, like they have shown through a traditional hybrid and hosted virtual machines in the form of a block diagram. So you know that underlying layer is the same hardware we are going to utilize. Okay, hardware, on top of that virtual machine monitor will be running. Okay, so different application servers will be working on with like VM1 to VMN. In between, any number of virtual machine as a using guest operating system, they can perform their functionalities. Okay, so there is one virtual machine monitor which will be monitoring the hardware resource utilization, giving the connectivity to different virtual machine host, which will be performing their own application. Okay, you can connect any number of virtual machines on top of the single hardware, but the controlling and monitoring, resource sharing, allocation, okay, that is going to be performed by using a VMware virtual machine monitor. Okay, this is the diagram. The same thing has been depicted here. See, traditional virtual machine, hybrid virtual machine, hardware layer, virtual machine, guest operating system, application, host operating system. See here you can have here one partition is going to be performing through a using virtual machine monitor, different guest applications using guest operating systems which will be performing. And here host operating system is nothing but the hardware which is performing on its own operating system. Okay, maybe Windows for example. Okay, it can perform its own functionality, maybe image reading. Okay, that might be one of the application you will be running. Some you are right, you are working on some other video processing for example, that is another application. Okay, like that you can run any number of different applications on the host OS. Parallelly you can also run like guest operating system which will be performing its own customized application platform by using virtual machine. Okay, that is nothing but your VMM monitors only these activities. Okay, and using host OS you can perform these functionalities. See here they have given how the performance and security is going to be provided. Okay, like different applications will be performing its functionalities using guest operating system on top on parallelly with the host operating system, right? But like data privacy and security is also very very important. So it needs to provide an isolation for each and every applications, right? So on top of that, even performance wise also, it should not slow down your performance because you are going to connect n number of applications parallelly because of the virtual machine. Okay, so in this particular slide they're describing about how the isolation is going to be maintained. Okay, and how the security is going to be provided even though if there are more number of applications will be running on using VMM. See here the performance how it is going to be degraded is the runtime behavior of an application is affected by other applications running concurrently on the same platform. You know that it uses the same hardware underlying resources, right? So but because you are going to connect different operating systems, it need not slow down the process of the entire system. Okay, that is it. CPU cycles should not be too slow, or you are using the same resource, cache memory, okay, main memory, disk and network access. So thus it is difficult to predict the completion time. So in case if there is a slower behavior, then it shows that your application might be affecting the entire performance, where your CPU cycles are going to be affected. Okay, it is using the main memory or the intermediate cache memory where the information will be stored for the temporary purpose. Okay, and your disk, that is storaging in disk or your network bandwidth should not be too slow. Okay, then performance isolation, a critical condition for a quality operating system guarantees in shared computing environment. See here, you need to take care of as much as isolation as possible between the applications, different applications which will be performing on the guest operating system and host operating system. So here VMM provides, it is a simpler and better specified system than a traditional operating system. Okay, so here one virtual machine you can run on one virtual machine monitor can monitor n number of virtual machines with its guest operating system. Okay, in that way it is making isolation, it is going to provide an isolation as well as performance wise also it is not going to be degrading the operating system performance. Okay, different applications with guest OS is going to be connected which will be running. Okay, so because of that VM works much simpler and better specified compared to a traditional operating system. See here, they have given an example of Xen, X series. Xen has approximately 60,000 lines of code. Okay, and denial has only about half, that is 30,000. So denial is only about our denial of attack is only see, it is going to generate 60,000 lines of code. Okay, but still it could able to perform very well. Okay, security vulnerability of VMM is considerably reduced as the system exposes a much smaller number of privileged functions. So here, in particular VM, you will be hosting different guest operating system, but at a time only one applications can able to execute through that guest OS, and it will be interacting with the hardware resources. So because of that, so like security wise it is less it is less attack with any virus or any other malicious functions. Okay, because it will be performing on its own guest operating system. Okay, so this is the one, this is the security measure VMware is VM, sorry, not VMware, VMM is going to perform.